Next problem, we have a 20-meter long steel pile with 0.5 meter diameter is driven into layered clay. So this is composed of around 1, 2, 3, 4 na properties. Determine the end bearing capacity, the frictional resistance using alpha method, the frictional resistance using delta method, and the frictional resistance using delta method. And lastly, the allowable capacity of the pile. Okay, so unahin natin si end bearing capacity. Ang kagandahan kay end bearing capacity, ang focus mo lang dyan ay yung pinakadulo or the pile tip. So kung ano man yung layer na nakapaligid doon sa pinakadulong part or pinakailalim na part, yun lang din yung i-consider mo for calculations. So again, the end bearing capacity QE P is equal to can or lata plus NQ. And yung C or yung cohesion is given dito sa pinakailalim na part, which is 50 kilopascal. So ito yung i-consider mo na layer dahil dyan nga nakalagay yung dulo ng tip or tip mismo. So C is equal to 50 kPa. The area of your pile tip is given 0.5 meter diameter. So to get the area of a circle, you just simply multiply pi over 4 by d squared. The pi r squared d squared. Pareho lang yan. Yan. Pwede mamaya mo na siya i-ano para mabilis. And then ang N for the end bearing capacity factor is 9 if no value is given. Wala naman yatang given, no? Di para mabilis, N is equal to 9. Usually, ang mga end bearing capacity, dyan lang din naman yan naglalaro sa numerong yan. Wala naman tayo masyadong mataas na end bearing capacity. Pag sa 9. Okay, so by direct substitution, this is equal to 50 kilonewton per m squared multiplied by the area of pi over 4 by 0.5 squared. This is square meter. And then your end bearing capacity 9 or factor 9. Then calculator na lang yan, no? 50 by pi over 4 by 0.5 squared by 9 is equal to, ayan. So 88.3570 kilo. That is the end bearing capacity of the pile. Ito na tayong Mars. Ay, sorry. Wait, let me erase this one. Now, the next, the next letter is more on letter B. Wait lang, palitan ko yung pointer. Gawin natin black clip. So, B is the frictional resistance. Frictional resistance using alpha method. So, ano ba yung alpha method? Going back to the main formula, CLAP, C-L-A-P, or C-A-alpha-P. Frictional resistance, or QSF, is equal to C-L-A-P. Ngayon, ito naman pagdating sa frictional, dahil tayo ay mayroong almost 4 na layer or properties ng soil na kinoconsider dito, ibig sabihin 4 na beses mo rin i-compute yung CLAP or CLAP. Tapos, ang summation na lang siya pagdating sa dulo. Okay, so that is the sum of all the frictional resistance due to the different soil layers. So, unahin natin for layer 1, we have the CU or C is equal to 35 kilopascal. Ang length niyan ay ito 2 meters. So 2 meters. Alpha given din dito ay 0.7. So that is 0.70. While the P or the perimeter of your pile tip is still 0.5 in diameter. Or to get the circumference of that, you multiply pi by the diameter. Pi by 0.5. So, layer 1, ang kanyang QSF1 is equal to C 35 by L by alpha 0.7 by P is 0.5 pi. And siguro i-calculate na natin agad, no? 35 by 2 by 0.7 by 0.5 pi. So that is, in terms of pi, you have 49 over 2 pi. So that is QSF1. Okay, going to the next layer of our file, we have layer 2. Okay, QSF is again CLAP or CLAP. Ang C ng second layer ay itong 35 kilopascal. Ang length is the second layer ito dito. So kung nasan yung dimension, pakisundan mo na lang. 6 meters. Ang alpha is also given dito sa problem, 0.7. And the perimeter is, pareho lang siya kasi uniform cross-section naman siya, no? So, 0.5 pi. And QSF2 is equal to 35 by 6 by 0.7 by 0.5 pi. And how many is that? That is 35 by 6. So, 147 over 2 pi. Next, layer 3, you have C is equal to 45 kilopascal. The length is this long length na yan, 10 meters. Your alpha is given also 0.75. And then perimeter is still the same of 0.5 pi. So therefore, QSF3 is equal to 45 by 10 by 0.75 by perimeter 0.5 pi. So, ilan yun? 45 by 10 by 0.75 by 0.5 pi. So, that is a total of 675 over 4 pi. Then lastly, the layer 4. So, ang C, cohesion is 50 kilopascal. The length is ito. So, 2 meters. Alpha is 0.9. And then P is 0.5 pi. So, QSF4 is equal to 50 times 2 by alpha 0.9 by P is 0.5 pi. Ilan yun? 50 by 2 by 0.9 by 0.5. 45 pi. And the summation of Q is equal to QSF1 plus QSF2 plus QSF3 plus QSF4. And ilan yun? Balikan natin yung una. We have 49 over 2 pi plus 147 over 2 pi plus 675 over 4 pi plus 45 pi. And the total of that using alpha method is equal to 49 over 2 pi plus 147 over 2 pi plus 675 over 4 pi plus 45 pi. 979.3915. That is kilonewton. That is how you get the frictional resistance using the alpha method. May kasunod pa, beta method naman. I forgot to mention that the start of water table for your water surface is at this point. So, dito sa may ilalim nitong 2 meter, yung start ng water table. Sabihin nitong uppermost layer mo is dry unit weight yung gamit niya, 17.8 kilonewton per cubic meter. Okay? So, bago tayo mag-proceed kay beta method, alamin muna natin yung main formula niya, that is B beta L sigma prime M P. Long is QSF is equal to L sigma M prime P, where beta is given naman per layer, ito 0.22, 0.27, 0.32. So, wala tayong problem dyan. Si length naman, given din siya per layer, we have 2 meter, 6 meter, 10 meter, and 2 meter. So, kahit mamaya na natin siya i-consider. Si perimeter naman, given din yan kasi that is the circumference of the circular steel pipe. So, the circumference is 2 pi r, or simply pi diameter, pi d. Okay, so makikita mo na yung P niya. Ang problema na lang natin is sigma prime M. And sigma prime M is the effective pressure at mid height. Diba? That is average vertical effective pressure at mid height of pile in a layer. So ito, i-imbestigahan natin kada layer nitong liquid. Okay, so if we have this long layer, given, we have 2 meter of soil, and then we have 6 meters dito, then we have 10, so extend ko lang, we have 10 meters, and then lastly, we have 2 meters. Iba't iba siya ng makukuhang pressure kasi kino-consider natin yung mid-height niya per layer. Okay, so kung magsisimula tayo kay layer 1, si layer 1 ay itong part na to, to get the effective pressure niyan, or delta prime M1 is equal to gamma H pa rin naman, pero ang iba't ibang property niya, such as unit weight saka height, ang i-consider mo. Ang unit weight nitong ating unang layer is 17.8. So, automatically, yan na yung gagamitin natin kasi wala naman siyang water na kasama. So, dry unit weight yan. So, 17.8 kilonewton per m cube. Okay? And then, ang height na i-consider mo dyan ay mid. Laging mid height. So, ang kalahati ng 2 meters ay 1 meter. So, 2/2 is your mid height, or 1 meter. So, ang iyong pressure at that point is simply 78 per kilonewton per square meter. Okay? So, yan na yung kay first layer. May second layer pa tayo. Pagdating natin kay second layer, the effective mid-height stress is gamma H pa rin, but ano ang i-consider natin? Okay, we all know that this is the first layer. Nadadagdag siya sa pressure na nararamdaman nitong pangalawang layer. So, ibig sabihin, automatically, this is a part of the equation. Okay, so 17.8 kilonewton per cubic meter multiplied by the total height of your first layer, 2 meters. Total na siya kasi nasa ilalim na tayo i-investigate. Ano po? So, kasama na yan dyan. Pack 1, pack all. Yan. And then plus, the effective stress naman of this layer. Okay? To get the effective stress of that, you have to multiply the unit weight, dry unit weight. So, 18 minusan mo siya ng 9.81 kilonewton per cubic meter dahil may containment siya ng tubig. So, nagbabawas siya na. Then, multiplied by the height of 6 divided by 2. So, ito ang kinukuha nating effective stress. 6/2 is simply 3 meters. So, i-add mo na yan and you will have effective stress at point 2 of 17.8 times 2 plus 18 minus 9.81 times 6/2. That is equal to 60.17 kilonewton per square meter. Okay, kana. Next, we have layer 3. So, at layer 3, intindihan po. Layer 3, we have here ito. So, the sigma prime M3 is equal to 17.8 multiplied by 2 meters plus effective stress nito. So, ilan na yun? 18. Minus 9.81 pa rin kasi nga saturated siya dito sa part na yun. Multiplied by the total length na. So, 6 meters plus the mid layer or kalahati nitong total height mo dito sa pangatlo, which is 5 meters. So, ilan yung unit weight? That is 18.3. Minusan mo siya ng water, so 9.81, multiplied by kalahati ng 10 meter or 10 over 2. Now, your effective stress there is equal to 17.8 by 2 plus 18 minus 9.81 by 6 plus 18.3 minus 9.81 by 5. Okay, so 127.19 kilonewton per square meter. Lastly, the fourth layer or layer number 4, we have sigma prime M4 equal to, redundant na lang yung mga nauunang part kasi kinukuha nga natin yung summation ng kanyang effective pressure. So, yan, copy mo na lang din siguro para mabilis. 18 minus 9.81 by 6 meter, the second layer, plus 18.3 minus 9.81 multiplied by the third layer is 10 meters. So, 10 plus, ito na lang dito sa dulo, we have 18.5 yung kanyang unit weight. Minusan ko siya ng water, 9.81. Multiplyan ko siya ng kalahati ng 2 meter or 1 meter. 2 over 8. Pareho. And now, your effective pressure at that layer is equal to 17.8 by 2 plus 18 minus 9.81 times 6 plus 18.3 minus 9.81 by 10 plus 18.5 minus 9.81 times 1. Okay, so the last one or the last effective pressure na na-compute natin is 178.33 kilonewton per m squared. Pero hindi naman yun yung final answers natin kasi this is just a part of the formula na i-compute natin sa BL lump or BL sigma P. Ay, okay. So, para makuha natin yung pinaka-tinatanong niya, wait lang. Duplicate. Wait. For a while. Okay. So, therefore, BL sigma prime MP is your skin friction resistance. Kukunin mo yung summation nun. QSF1 plus QSF2 plus QSF3 plus QSF4. Diba? Pwede ba idiretso na natin para at least tuloy-tuloy na lang tayo pag-calculate later. Okay, so QSF is equal to, ano yung nauna nating beta? 0.22 given 0.22. The layer or the height of your layer 1 is 2 meters multiplied by sigma M1 17.8 kilonewton per square meter. So you have 17.8 kilonewton. Then lastly, your perimeter is just your circumference, 0.5 pi. O di okay ka na sa QSF1. Next, QSF2 is beta. Ang beta nun is 0.22. So dito mo lang din yan. 0.22 by the second layer is 6 meters times yung nakuha natin kaninang sigma is 60.17 kilonewton. So you have 60.17 multiplied by the perimeter 0.55. Okay ka na rin sa QSF 2. Next, the third one is going to be beta 0.27 yung given. Ang kanyang layer is 10 meters. Ang kanyang effective stress is 127.19. Ulat natin. Kilonewton per square meter. And then, pareho lang din sila ng circumference kasi hindi naman nagbabago yung cross-section. So, pang-apat, 0.32 yung given na beta. So, 0.32 multiplied by length of 2 meters. So, 2m by your effective stress is 178.33. 178.33 kilonewton per square meter by, lastly, the perimeter, 0.55. So, total, if you calculate that, you can have 0.22 times 2 times 17, 8, 5.55 plus 0.22, 6 times 60 times 17, plus 0.55 plus 0.27 times 10, plus 127 times 5, plus 0.32 times 2, plus 178.33 multiplied 0.55. So, all in all, the QSF is equal to 855.7708 kilonewton. That is now your skin friction resistance using the delta or beta method. Letter D. Haba pala nito. No, frictional resistance or QSF using delta method. So to get that, ang unang formula natin kanina is delta L sigma prime M plus 2C multiplied by P. Tandaan. So delta L times sigma prime M plus 2C by P is your QSF using the delta method. Ngayon, na-compute man na natin yung kanyang iba't ibang effective pressure at mid-height gaya nito. So, pwedeng i-direct substitute na natin siya agad-agad. Meron naman kasing given dito na delta sa problem. Ayan, 0.15, 0.15, 0.18, 0.2. Ito namang L or length of the pile. Ayan na ulit. 2, 6, 10, and 2. Ano pa ba? C, cohesion. Given din sa problem. 35, 35, 45, 50. And the perimeter is just the circumference pi d. E di, diretso na natin. QSF is simply the summation of QSF1 plus QSF2 plus QSF3 plus QSF4. Yan. And now, ang kunin natin isa-isa yung mga values. So, at layer 1, you have 0.15 na delta multiplied by length is 2 meters. Multiplied by your effective stress at 0.1 is 17.8. Okay? So, 17.8 plus 2 times ng cohesion, 35. Multiplied by perimeter, 0.55. Plus, the second layer is 0.15 pa rin yung kanyang delta. Ang kanyang length is 6 meters, this one. So, 6 times the effective stress at layer 2 is equal to 60.17. So, ilan yun? 6017. plus twice ng cohesion niya, 35 pa rin naman yung given, multiplied by, ano na to? Circumference, 0.55. Plus, the third layer is 0.18. So, given siya. 0.18 times length is 10 meters multiplied by the effective stress at layer 3, 127.19. So, 127.19 plus twice ng cohesion is 45 dito sa layer 3 multiplied by 0.55 plus the last layer finally is equal to 0.2 multiplied by the total length is 2 meter multiplied by the fourth, effective stress 178.30. So 178.33 plus twice ng cohesion 50 times 0.505. Ay, suma total, ang total niyan ay ilan? So calculator na lang to ha. I-input ko na lang siya directly.
Sinatimes ko natin. Pag yun yung kapyaran, super run.
Ayun, ang nakuha ko is 1,014.3684. That is in kilonewton. So that is how you get the frictional resistance using delta. The last one being letter E. Wait lang. Applicate ko muna. The last part is the allowable load capacity of the pipe. So again, from the first formula, ang allowable is simply QUP over Fs, where QUP is the sum of the two na na-compute natin, which is the end bearing capacity plus the skin friction resistance. So kung isusulat natin siya dito pabalik, we have wait lang, hindi ko na masulat. Q allowable is equal to Q end bearing capacity plus Q SF divided by factor of safety. Ngayon, si factor of safety, hindi ko siya nailagay dito. Pero let's say 3 siya. I forgot to mention. So, Fs is equal to 3. Meron na tayo kanina na po. Bearing capacity that is equal to, balikan natin, so 88.357. So 88.357 kilonewton. Okay. Ngayon, dahil nag-investigate tayo 3 beses dito using alpha, beta, saka delta method, na kaya ang pwede nating gamitin? Is it 114.3684? Is it 855.77? Or yung kanina na 979.3915? I think it is safer to assume kung ano yung list na pinakamababa nating nakuha. Kasi at that bearing capacity or that frictional resistance, mababa pa siya as compared dun sa iba. So, kapag na-loadan siya ng automatically 855.77, mariresist pa niya yung ganyang load, 855. Kesa naman dito sa 1014.3684, so, inaantayin mo pang ma-attain niya yung 1,014 kilonewton na load bago siya mag-carry talaga. So, ito yung mag-govern. Yung sabihin na. Ito ang mag-govern. So, aantayin mo pa bang sobrang taas na ng load bago ka magkaroon ng factor of safety or bago mo siya i-consider na yun yung load mo. So, that is medyo alanganin ka doon. So, ang nag-govern natin is 855.7708 which is the lowest frictional resistance na nakuha natin. Okay, so to get the allowable now is equal to 88.3573 plus QSF 855.7708 dividing both sides by factor of safety 3. That's right. Yung factor of safety, nakalimutan ko lang ilagay sa problem. Pero, yeah, 3 yung kanya. Alawa po. So, therefore, 88.3573 plus 855.7708 divided by 3. And the allowable bearing capacity is therefore 340.7094 kilonewton. So, yan yung itong nakaturo dito. Ang loading mo sa taas ng iyong superstructure or yung bigat ng iyong building, dapat hindi siya lumagpas ng 314.794 kilonewton para kaya pa siyang i-resist nitong ating pile gamit yung kanyang mga end-bearing capacity saka yung iba't ibang skin friction. So, that is the logic there. 314 sa.